Okay, hi and welcome to Mr. Hallam's Algebra 1 video notes. Today we're going to talk about statistical stuff, which is we're going to focus on graphs of statistics, the way that they look, and then finally we'll get into a little bit about frequency. But remember, today is mainly about just kind of understanding the basics, things that you may have seen before that we're kind of reviewing. So let's go ahead and get right down into it. First thing you'll see up here on your notes is that we've got the different shapes of the graphs that we're going to look at. We haven't officially gone through how to graph yet, but let's look at the shapes so that when we do graph, we can make a little bit of sense of them. Some of this here will be what we play off of quite a bit later, is the shape versus making them, and what does that mean to us. So the first one that you're going to see here is this uniform shape. What it means is basically all the bars, everything that we're looking at is relatively even. That would be a uniform shape of a graph. What we're generally looking for is what we refer to as symmetric. That means that the data is kind of really nice. Means that your mean, median, and mode, I should probably draw a vertical line here, is, or not necessarily your mode, but your mean and median then are really close together. And it's symmetric. It means it's nice. It's good to work with. We can run into symmetric that's other than normal. And in this case, this becomes a little bit more difficult to use, and we don't do as much with it. So I'm not going to X it out, but it is something that we'll see. But again, this is the one that we're kind of after. If we find that, we're pretty happy. Okay. Other shapes that we'll see, and not that it doesn't make us unhappy to have them, but we can have a positively skewed and a negatively skewed. If it's positively skewed, what it means is that some of the data is tailing off to a certain direction. That's the term skewed. If we refer to it as positively skewed, let me highlight one more thing here. The part that we like to say a lot is that it tails to the right, or that the values are kind of leading to the right side. So instead of being symmetric, where everything's even on both sides from the center of our data, our central tendencies, right, that there seems to be a tailing action. And if it tails to the right, we like to say it's positively skewed because it's going towards the larger positive values. So there's kind of a tail. And if you want to draw a little tail there, you're more than welcome to. If you can draw a tiger tail or something, whatever makes you feel better. But the tail is to the right in that case. Negatively skewed then is going to be when it tails to the left, or that these values are kind of trailing off and they lead to the left side of the graph. So it would be symmetric, right, if it ended right there, but there's extra values that are tailing off to the left, or the negative values. So this one's going to tail to the negative, so your tail would be on this side this time. And again, I don't know how I'll make a tiger tail, but there's a quick representation. All right, that means that for us, I'll just kind of mention it quickly, is what that means to us is that the mean and median are not going to be the same. We'll identify that the median will always be the middle of the numbers, but the mean will be pulled by these values. So the mean may be a little bit separate, so there'll be some space between them. Where in symmetric, the mean and the median are going to be relatively close together. So that's kind of how we would tell that if we were just looking at the data versus actually graphing it. In this case up here for the positive, since I'm doing this, there would be a separation. The mean would be pulled to the right direction because of these values out here, because they affect the mean, right? And we wouldn't call them outliers. Outliers would be something that would be way out here, but these values, how they tail to the right, is going to pull that mean over, where the median is still going to be the middle of the numbers. And remember, a vast majority of your numbers are going to fall in that main section where there's most of the numbers accumulated. All right. So now that we have a kind of an understanding of that, let's talk about different types of graphs that we'll use within the stats section. Dot plots are probably the first thing that you're going to use. Really, a dot plot's just a number line, and then you start dotting the frequency of the numbers that occur in a data set for that particular case. So, and we stack the dots so that it represents the higher the stack of dots, again, hopefully equally spaced, of course. That means that there's more of them in that category. So let's go ahead and do one. I'm sure you're pretty familiar with them, but it won't take long here. Here's a set of data. It looks like students, it takes for them to get to school in a math class. They gave us a nice set here. What you want to do first is make sure that you have some form of a number line that's equally spaced, however that happens to be, if I give it to you or if you make it. And you'll notice I did my best to make an equally spaced one. From this part then, all we're going to do is start mapping off our points. So there's a 15. So I'm going to find 15 where that would be. I'm going to find where I'd like to put it, probably just a little bit above my number line, and then I'm going to start recording these down. So I'm going to pause here and put the rest of these values in so you can see what it looks like, and you do the same, and we'll meet back in a second. Okay, so there's the dots put in for you. You can see that I've gone through and marked all of them. What you see here is a fairly symmetric data if we're talking about that. And again, when we get to our actual questions and activities in class, you'll get to work with that a little bit more and see what that really means. But you're going to guess somewhere in there, and I didn't do the median for this quite yet, but I'm going to guess it's somewhere in the middle because there's a nice even distribution on both sides. There may be a little bit of a lean this way because there tends to be a little bit of grouping here versus the other side. So I would suspect that maybe the mean being pulled, oops, I did that upside down. The mean may be pulled a little bit to the left. And this is really kind of the things that we're going to do with these, and I'll put median for that one. That's going to be what I suspect. So the next part of this question then is to go ahead and fill that in. So let's check to see if our estimate was right. I'm going to pause and write that in. Actually, no, I'm not going to pause. I'm going to show you how to do it in the calculator one more time just so you're kind of clear. Again, with this one, you're going to turn your calculator on. You're going to clear your list, which would be second memory, but I want to keep my information, so I'm not going to do that. So second memory would do this, and then we would click 4 for clear all list. But I'm going to go back into stats. I'm going to pretend that I entered my data, which I have. It's actually in L3 here. You don't have to worry about that. You'll just work in L1. And then I'm going to go back to stats, and I'm going to calculate my one variable statistics here. So I'm going to go ahead and enter on that. I want to see the data in L3 for this one, so this is where I would change that on my calculator. You would just use L1 so that you don't just put everything in L1. I'm going to calculate. So it's going to give me my information. I'm going to go ahead and write that down, and then we're going to talk about it. Okay, so here we're back. You notice that we hadn't described the shape for this one, which says symmetric. Again, we believe it to be very symmetric, maybe with a slight pull or a slight skew to the left there, towards the negative side. But what else we notice here is that we did say our mean was going to be a little bit lower, and we can see that it's 14.36 compared to the median. And our guess then, based off that little tiny cluster that wasn't on the other side, was right. So you can see what you're going to find out through our activities is that the mean is pulled by values. It gets pulled, or values that are further out carry more weight. So these are heavier, and we'll do a little activity in class that'll help describe that in a concrete nature. You actually get to see it, where the median quite literally stays near the center of the points because it is in the middle. We count to the middle for that one. So what does that mean? It means that there was a tiny little skew, but you would still call this symmetric. It's not skewed by any sense. They're very close together. If we had a greater distance between them, then we would start talking about skewed data. Again, these are our terms of variability, which means how good is the data. And standard deviation reflects to mean, and so it looks like 3.44. Is it good? Sure, it looks pretty good. You saw some of the examples in class, but really until we compare these to something else, these don't have a ton of meaning for us at this point. Our RQR, again, for this one is 5. Again, it looks relatively small comparative. It looks like a nicely packed set of data. All right, so let's scroll down and see if we can do a histogram now. Now, I know there's a lot of data there. You're going to have to enter that, so get ready for it. But a histogram then is just a graphical representation, kind of the dot plot, if you will. We just stack them up in nice rectangles, so it's a little bit prettier, a little bit more organized. It's kind of the difference between the two. They will look the same, except for one will have bars in it. So for this particular set of data, it looks like it's a class test scores here, a class set of them. So if we were looking at test scores, we're going to kind of categorize these a little bit because we don't want to place a number line between, well, I forget what our low is, it's in the 40s, between 40 and like 99 or 98 seems to be our high. That's a lot of data points. With a dot plot, that would be a lot. So in this case, what we did is we went ahead and made categories of them. So for a value category, we're going to count all of the frequency for those. For B's and C's and D's and anything less than that. And we'll count those up. Relative frequency is going to basically be the percentage that these occur inside this set of data. So you're going to basically take the frequency and divide it by the number total in this set of data, which happens to be 50. So it just basically gives you the percent of that category, how much is in that particular category. So I'm going to go ahead and show you quickly, but then I'm going to pause the video here. I'm going to do the frequency and relative frequency here. But what you're going to do, and you're going to do this while I'm pausing, is that you're going to count these, and hey, there's a 95, there's 1 in the 90 to 100 or 100 to 90 category, 2, you're going to count them, and then you're going to put that frequency there. So I'm going to pause and do that, and then I'll meet you back here in a second. Okay, so you see I've done that, and if you went through, hopefully you matched the numbers. There's a lot, so sometimes you miss one. I know I did the first time I did it, but you'll look here at our frequency for 100% or A class, there's 6 people in there. It happens 6 times, whatever the particular scores are in that range, and that's about 12%. So again, how did I get to 12%? I took 6 and I divided, well, let me put the equal sign on the other side because that's really what I intend to do. I took 6 and I divided it by 50. And that's going to give me that 12%, or 0.12 right now, but it's essentially a percent. And then I took 26 and I divided it by 50 to get that one. So that's where you get your relative frequency from. That will be useful when we do some examples, the ability to have the percent per category or per event, whatever happens there. Next, our job is to go ahead and make a histogram. Histograms are going to be very similar to what we did with the dot plots. We'll need a second scale for that, so we'll need 2 scales. We know that our range is going to be from about 40 to 100, so we need to arrange some type of a scale on here so that we can account for that. So you're going to go ahead and figure out a scale, whatever happens to work. I'll probably give you number lines occasionally, but you'll have to draw your own. So figure out a scale that kind of fills this up, and you'll also need to figure out a scale that moves up and down. So I'm going to let you do that, and I'm going to do the same, and then we'll meet back together in a second. Okay, so we're back. I've made a scale here. You can kind of see I broke it up as well as possible so that it's as big on that area that we're going to use. Again, graphs are nice when they're larger. So you can see that I've got from 0 to 30 here and this will be our frequency, right? So this is the number of occurrence here, and we've got the highest number frequency is 26. So that works pretty good at 30. And then I spread that out between all of our ranges. So between 100 and 40 seems to be our lowest value, or at least our lowest range at the bottom. So at this point, what we're going to do is we're going to go ahead and attempt to start to sketch this histogram in. Now, a couple rules: make sure that your histogram bars touch. They must actually occur and touch together, so they're going to be bound on each end. But you want to go ahead and estimate where our first category is. So in this case, we've got a frequency of 6. So we're going to look over here. Here's 10, here's 5, so 6 is somewhere just above. So I'm going to go ahead and take a line over and sketch that in. Make sure it goes all the way over to where my boundary for that category is, and then I'm going to sketch that down. I may shade it, I may not, and we'll sketch that in. All right, so why don't you go ahead and put the rest of those in. I'm going to pause and do that myself, and then we'll meet back. Okay, so I'm done with my histogram here. What you'll notice is that it gives us something similar to what we saw in the dot plot. There's some type of a shape here. Our job now would be to kind of analyze the shape of it. In this particular case, hopefully you're noticing that this one tends to be skewed a little bit, right? We tend to see some values tailing off over here. Looks very symmetric. At the first 3 bars, if you look at just these 3, there's your symmetry to it. Looks a nice symmetry, but there's these extra bars on the right. So it tends to be to the positive side, or a positive skew. And that's what we would hear when it says right here on the second part where it says describe the shape. That's what we'll put there. Is we'll go ahead and say that that is a positive skew. I'm going to do this in red. So I'm going to go ahead and put this in my calculator. I'm going to grab the rest of the information and fill this in, and we'll meet back in just a second. You do the same as well. Okay, so I filled that in and went through and put that in. You can find that on your calculator. Again, hopefully you typed all that in. You took the time to do it. You find out that the mean is 78.44 and our median is 81. When I did that, I realized that there was something that I probably should have rearranged so that it was a little bit more standard. I started with my first category sometimes when I'm not paying attention, and I put them down. Generally, though, this category probably should have been on this side since it's a higher number, right? So that we would increase. So when I say that it's skewed towards the positive values, which we already noted and took note of, we're not actually skewed towards a positive, we're actually skewed towards the negative because I reversed my scale. So putting your scale in is just as important as doing some of the work. So we don't want to say that this is positively skewed. We want to say that this is negatively skewed because it's skewed towards these smaller numbers. And again, it is skewed to the right, which is the exact opposite of the definition because I needed to move my scale around. So go ahead and ignore that because I'm not going to redo it for you, but you get the concept. All right, so if we look at the rest of this, we should have seen that there was a difference between our median, which expect our median to be somewhere over here near the symmetry, and that our mean will be pulled by this skew, and again, it's to the negative side, so we should have had that mean be pulled by those values over there, and you'll notice that the mean is a little bit lower than the median, and that would be the case of these smaller numbers pulling it. Again, should be on the other side. All right, so the last thing we're going to talk about then in the shape negative and positive skew. See this scale right here? The scale's right. Smaller values on the left, larger values on the right. We're going to talk about box plots, which is really just another construct of the same thing that we've been doing. So for this one, you've got a set of data. You could put this in order. You can do this by hand. or you can throw it in the calculator. I'll probably ask you to do it both ways, so make sure that you're capable of doing it in either fashion. But let's talk about this. We've already done some of these values before. We know what the first and third quartile are. We can do those both by calculator and by hand. Hand is we find the median, and then we cut the halves in half. We did that in class. We know how to find the IQR, but what we'll find out today is that the IQR is actually, this is your quartile 1 here, this is your quartile 3. The quartiles are the edges of the box that's made for the box plot. The center line is the median that you'll find, and then we connect that up. That represents the variance for median appropriately because it's all there. You have your quartiles. Interquartile range is that range here. So the smaller the section of this box, the better the data is. So you'll notice that this pink one is larger than that one that we were just doing with the negative skew. And again, this is the same as the shapes of the graphs that we saw in the histogram part, right? Skewed to the negative values, pulled to the negative, tails to the negative. But you'll notice that this has a better variance, which means this data is a little bit more tightly packed than this data here. So we'd like to see a smaller interquartile range or smaller box, if you will, when we're drawing these. That means there's less variance in our data, and that's always a good thing. Let's talk a little bit about outliers. Outliers then are values that don't fit our data, that seem to be in the exception to the rule. And to find that, it's a pretty simple little formula, which is you take your IQR and you multiply it by 1.5, so you make it half bigger essentially, right? And you subtract that from the lower quartile. If that point is farther than that out, then that becomes an outlier. And then on the other side, we take the IQR plus a half, and we add that to our quartile 3. If they make it further out than that, out here like these, then we also call those outliers. We ignore those points because what they'll do is they'll distort our mean, and they'll not change our median so much because outliers don't affect median, but they will distort our mean, and then we'll get some readings that maybe we don't really want out of that. It is not a true explanation of the data. So let's go ahead and make a box plot. We're going to keep this quick because we're at 16 minutes already. So looking at this part here, again, make a number line evenly spread across your data. So you want to include that whole range from whatever your low to high is. This isn't in order, of course, yet. So we're going to go put it in our calculator for this time. And I'm going to come back with that information, and then we'll actually draw in our box plot. Except for the fact that data's right here. I've already put it into the calculator, and it's right there. So I put all that into the calculator. You should hopefully have done that as well. If not, go ahead and do that now. Pause the video and then come back and we'll pick up. But here's the information that came from putting this set into your calculator. We find out that our median, or I'm sorry, that's our minimum. Here's our median. This is the one I want. We want to start with that one usually. I don't know why. You don't have to. I generally do. Find the median first. So I'm going to go in here and find the median. That's going to be this line right here. So let me change the green so you can see. Well, actually, I'll change the blue so it stands out. So here's our median. I'm going to mark that with an M. What you'll do there is you'll go somewhere above your number line and you'll draw a nice tall vertical line. That's going to represent the center of our box. Usually I go to the lower quartile, the quartile 1, and I mark that next. Again, any order, it really doesn't matter what you do here. But 29 is marked here, so I'm going to go ahead and there and draw another nice vertical line. I'm going to call that quartile 1. So I'm kind of seeing the shape of the box perk up a little bit. I'm going to go ahead and mark now quartile 3, which is 42. I've got that marked off as well. So I'm going to put quartile 3. Again, nice vertical line. And then I'm going to go ahead and connect the edges of this box. So there is essentially your IQR. That's your interquartile range. You got your median, your quartile 1, your quartile 3. That's what makes that up. The other two parts, or the whiskers, if you will, come from our minimum values. So our minimum value in this set happened to be 23, which is here. So this is our minimum value. And what you'll do there is you'll do a smaller vertical line and you'll attach that to the box for the whisker. And then our max value is 51, marked off here. So another smaller vertical line and then attach that. And that makes your box plot. Again, you can see if they're skewed. You can see that up here. If it's negatively skewed, you're going to see a tailing action to the left or the lower values. If it's symmetric, it should be relatively even, and then positively skewed, you're going to see that tail action or that longer whisker to the right or the larger positive values. Do we have any outliers for this particular data? What we're going to do for that then is go ahead and take your IQR, and we're just checking to see if we have any. I'm going to tell you that we don't, but I'm going to show you how you look for them. So you take your IQR, you're going to multiply it by 1.5, so the IQR times 1.5, right? Make it a half bigger. It's going to give me 19.5. So that's the value we're going to use to see if we have any outliers. So if we go back to our formula here, let's check to see if we have any minimum or smaller outliers. So we're going to take that value and we're going to subtract it from quartile 1, which was 29. I'm going to subtract 19.5 from that, and I'm going to find out that no, I'm going to end up with what, 19 minus 9 is 10, 10.5, 9.5. All right, so what we find out there is that our minimum value is, what was our minimum value? 23. So 23, we don't have any values there. So if we went down here at 9.5, we had a value somewhere in this range, we would call that an outlier, but we don't. So let's check on the high side. So the high side, we're going to take, this time, add this value to the quartile 3. So our maximum value, or I'm sorry, our quartile 3 was 42. We're going to go ahead and add that 19.5, and we come up with 61.5. And again, so if we had a value over here at 61 in this area and larger, then those would be outliers. So you can kind of see where that range is. We didn't fall into that, so we have no outliers for this particular one. But at this point, at 20 minutes, we've gone through everything that we need to do. You've been able to make a dot plot, a histogram, and a box plot. You've seen frequency, and you understand the tailing action or skewed action of particular graphs. So we can talk a little bit about mean and median and how that reflects in them, right? We've also done that. All right, so I'll see you in class for some homework, and we'll talk to you later.